Okay, so our middle school children want to know if you're the real deal. So why don't you start off with a small introduction about yourself and your work?
Sure. My name is Eric Norman. I'm a professor of nuclear engineering here at the University of California at Berkeley. I have a PhD in nuclear physics from the University of Chicago. I teach low-energy nuclear physics for nuclear engineers here at Berkeley. And my research is in the area of low-energy nuclear physics. These days, much of it has to do with non-proliferation and homeland security.
Okay, so the students in Washington, they want to know what the difference between nuclear fission and nuclear fusion is.
Right, that's a good question. So in nuclear fusion, what happens is we take light nuclei and bring them together and make them fuse together and make a heavier system. And in this process, all of the neutrons and all of the protons that were in both of the light nuclei fuse together and make a heavier system, which then may spit out a few neutrons and protons, but you build up heavier nuclei that way, and in some cases you produce energy. In nuclear fission, the exact opposite happens. You start with heavy nuclei, you excite them in some way, and they fall apart and make lighter nuclei. And again, energy can be produced. In the nuclear reactors we have today, the way we generate energy is through nuclear fission. In the reactors we hope to make someday, it'll be the opposite, it'll be the fusion reaction. But it turns out, for various reasons, it's a lot easier to make fission happen in a controlled way than it is to make fusion happen, right?
Correct. So it'll be almost like how the sun creates its energy, by fusing hydrogen.
Correct. The sun and almost all stars are fusing hydrogen nuclei to make helium, and that produces energy, yes.
Okay. So is fusion possible today? And if not, when will it be possible?
So we do fusion all the time. It's just that at this point we can't get more energy out of the fusion reactions than we put in. So it isn't economically feasible to generate electrical power that way. There's a very large project now going on at the Lawrence Livermore National Lab, about 50 miles from here, called the National Ignition Facility, where the hope is that eventually we will be able to get more energy out through fusion reactions than the laser beams put in. So technically, yes, it is possible. We haven't managed to get there just yet, and I hope students like you will be able to do this and help us in the future and make fusion a reality.
Okay. What about, today we talk about green energy. Would nuclear fusion be considered green if it were possible to harness energy?
So, let me see if I can explain this in a simple way. None of these processes to make energy are totally neutral in the sense of environmental impacts. Fusion would be less environmentally problematic than fission, and the issue has to do with the products that are created as a result of either fission or fusion. In the fission reaction, when you split the heavy nuclei apart and make lighter ones, many of the lighter ones are themselves radioactive, and some of them have very long half-lives, and that means it takes a long time for them to decay away and become stable. So we have to think about how we would dispose of nuclear waste. And in this country, we haven't actually sorted that out yet. In fusion reactions, you still make some radioactive nuclei, but generally their half-lives are much shorter, and so the waste disposal issues are a lot simpler. So yes, fusion would be greener than fission, but not totally benign.
Okay. So one last question. I'm sure that the middle school children in Washington are aware of the Daiichi nuclear plant in Fukushima,
right,
that caused radioactive water to spill out into the ocean.
Into the ocean, yes.
So they were wondering if nuclear fusion is also dangerous in a similar fashion.
So as I said a minute ago, there will be radioactive products from fusion as well as from fission. There will be fewer of them from the fusion, and as I also said, many of them will be much shorter lived. And so it will be less of an issue if a release happened from a fusion power plant than it was from a fission power plant like Fukushima.
Okay. Thank you very much.
Sure, you're welcome.